Okay, now let's say this question which was asked in IITJEE exam. The statement of question is quite big, so what I've done, I have put this figure and we'll understand the question through this figure. Question is there is a seashore, okay, and this is sea. Sea is on this side. There is swimmer S here in the sea, okay. This is nearest point on the shore at distance D from the swimmer, and house of swimmer is on the shore at distance L from point A. This is house of swimmer, okay. Here all the distances are in kilometers. This is D kilometers and this is L kilometers, okay. Now S can swim with the speed of u kilometer per hour and can walk with the speed of v kilometer per hour. Here u is less than v. Mostly it happens, okay. Generally लोगों का swim करने का speed walk करने से कम होता है. यहाँ पे ये दिया गया है, ठीक है. Now swimmer wants to reach his house in the shortest possible time. स्विमर जो है अपने घर जाना चाहता है शॉर्टेस्ट पॉसिबल टाइम में, ओके. ही कैन swim all the way to point B, okay, or he can swim and land at some point here between A and B and then walk from this point to his house, okay. Now we have to find the shortest time in which he can reach his home, okay. Then we have to find the point at which he will land here. हमें वो पॉइंट निकालना है जहाँ पे स्विमर यहाँ पे लैंड होगा जिससे उसका घर जाने का जो टाइम है वो सबसे कम हो. कैसे ट्राई करेंगे? ऑब्वियसली व्हेन ही स्विम्स ऑल द वे टू हिज होम, टाइम टेकन बाय हिम वॉन्ट बी द शॉर्टेस्ट. जब वो यहाँ से सीधा स्विम करके घर पे जाएगा तो वो टाइम शॉर्टेस्ट तो नहीं होगा, बिकॉज द स्पीड ऑफ स्विमिंग इज लेस देन द स्पीड ऑफ वॉकिंग. Okay, u is less than v, okay. So for the shortest time in which he can reach his home, he will land somewhere here on the shore, okay. Suppose this is point C. He swims from this point to point C, okay. Let's draw this line, okay. He swims this much distance, okay, and then walks this much distance, okay. इतना swim करेगा और इतना walk करेगा, but we don't know what is this where is this point. We want to find this point such that time taken by him to reach the home is the shortest, least, ठीक है. कैसे करेंगे? Now point C is variable, okay, so we introduce a variable here. Suppose this is x kilometers, then CB will be L minus x kilometers, okay. Now from this right angle triangle, this distance will be root d square plus x square kilometers, okay. That means he swims root d square plus x square kilometers and walks L minus x kilometers, okay. This distance he swims and this distance he walks, okay. Now we have to find the least time in which he can reach his home if he lands here, okay. Here x is variable, so definitely function of time taken by him will be function of variable x. कैसे आएगा वो function? It's simple. We have speed of swimming, okay. Then time taken by him to reach from this point to this point will be it will be distance upon speed, okay. So time taken will be root d square plus x square over u plus time taken by him to reach from this point to this point will be L minus x over v, okay. Speed of walking is v, so time taken will be L minus x over v. This is function of x, this is time function tx, okay. Now we have to find minimum value of this function, okay. तो क्या करेंगे? We differentiate this with respect to variable x. x के respect में differentiate करते हैं. We get dtx over dx is equal to 1 upon 2 root d square plus x square multiplied by derivative of this which is 2x, okay, into u here, okay, minus 1 upon v. Derivative of this is minus 1 upon v, okay. And for point of minima, we compare derivative to 0, okay. From this we will get value of x. Here 2 gets cancel out, okay. We get x over root d square plus x square is equal to u upon v, okay. From this we get v square x square is equal to u square d square plus u square x square, okay. And from this we get x is equal to ud upon square root of v square minus u square. I am considering positive value because x will be positive, okay. Now we have to verify that this is point of minima. कैसे verify करेंगे? We can use second derivative test, okay. Derivative of this will be d square of tx over dx square. This will be using quotient rule here. It will be 1 into denominator, okay, minus derivative of denominator root d square plus x square derivative. It will be x over root d square plus x square multiplied by numerator divided by square of denominator, okay. Here we have 1 upon u also, so here we will have d square plus x square, okay. Let's simplify this. Here we will have d square plus x square minus x square means d square. So this will be d square upon u multiplied by d square plus x square power 3 upon 2, okay. Now definitely this will be positive for all values of x, okay. ये हमेशा positive होगा. So this will be point of minima. ये point of minima होगा. That means swimmer will land here at point C, whose distance from point A is this, or distance from his house is L minus ud over रूट वी स्क्वायर माइनस यू स्क्वायर, ठीक है. स्विमर सी जो है वो अपने हाउस से इतने डिस्टेंस पे लैंड करेगा तो उसका घर जाने का जो टाइम है वो लीस्ट होगा, ठीक है. लेट्स स्टार्ट नेक्स्ट क्वेश्चन. ओके, नाउ लुक एट दिस वन, वेरी इंटरेस्टिंग क्वेश्चन. क्वेश्चन है द लोअर कॉर्नर ऑफ अ लीफ इन अ बुक इज फोल्डेड ओवर सो एज टू रेज द इनर एज ऑफ द पेज. Then prove that the fraction of the width folded over when the area of the folded part is minimum is 2 upon 3. Here I have one book, okay, and this is one page or leaf of the book. This is lower corner of the page. Now this is folded over. This corner is folded over so that it reaches the inner edge. This is the inner edge, okay, where there is a binding, okay. Now okay, first let me make the crease here, okay. So this is the folded part. It is a triangle, okay, and this is the folded width. ये जो है वो folded width है ना, okay, जो width fold हुआ है. We have to prove that the fraction of the width folded over when the area of the folded part is minimum. This is a triangle folded part. When the area of this folded part is minimum, we have to prove that the folded width is 2/3 of the actual width. ये जो folded width है, this folded width is 2/3 of this actual width. Okay, let's draw the figure. Figure draw करते हैं. Here this is the leaf of the book, okay. This is lower corner and this is the inner edge, okay. Now we are folding this so that this corner reaches the inner edge, okay. So suppose it is folded like this, Okay, this is the crease of the fold. Okay, this corner reaches here. Okay, let me check this. How much is this? Okay, almost here. Okay, so this is the folded width. Okay, let's join these 2 points. This is this length. Okay, these two lengths are equal. This part after folding comes here. Okay, and this part after folding comes here. Okay, so these two lengths are equal. Okay, and this is the folded part, which is a triangle. We have to prove that when area of this triangle is minimum, then this folded width is 2/3 of this actual width. Suppose actual width is a, actual width हम a assume कर लेते हैं. ठीक है, let's draw this line here, and dotted line. Okay, this is also a. क्या करेंगे? We have to minimize area of this triangle. Okay, so we will try to get the area of triangle in the form of some variable. Definitely this area will be variable because we can put this corner anywhere on the inner edge. Okay, so ये triangle variable होगा, this triangle will be variable, so its area will be also variable. Now we introduce a variable here. Suppose this is x. Suppose points are A, B, C, D, E and F. This angle is 90 degree. Okay. Suppose BC is x, then AB will be A minus x. Okay. Then FB will be also x. Okay. And AF will be square root of x square minus a minus x whole square. This is square root of 2ax minus a square. Okay. Now to get the area of this triangle, we need one more side. कैसे आएगा ये side? How can you find one more side? Either this or this. Now here we have similar triangles. Can you tell me which two triangles are similar? Suppose this angle is theta. Suppose this angle is theta, then this angle will be 90 minus theta. Okay, this is 90, so this angle will be theta. Okay, so this angle will be 90 minus theta. Okay, so now triangles FAB and DEF are similar. Triangles FAB and DEF are similar. Okay, here we have length ED. Okay, so we will try to get length FD by comparing ratio of corresponding sides. We get this is A. Okay, so we have here A upon A is opposite to angle theta, and here opposite to angle theta side is root 2ax minus a square. This is equal to, now we want FD, so we write here FD over, this is right angle. Okay, and here opposite to right angle we have length x, so we have here FD over x. Okay, so from this we get FD is equal to ax over square root of 2ax minus a square. Okay, now we can get area of triangle BFD, area of the folded part. It is 1 upon 2. Suppose area is delta, so area is 1 upon 2 multiplied by this length multiplied by this length. Okay, so we have area ax square 1 upon 2 into ax square over square root of 2ax minus a square. This is function of variable x. Okay, now we have to find minimum value of this. Okay, before that we simplify function. This is equal to 1 upon 2, in fact a upon 2 multiply by 1 upon, I take this x square in denominator, so inside square root I will divide by x power 4. I get square root of 2a over x cube minus a square over x power 4. Okay. Now minimum value of this function will occur when value of this function will be maximum. इस फंक्शन का मिनिमम वैल्यू तब होगा जब इस फंक्शन का वैल्यू maximum होगा. So we consider this function, suppose this is function fx, okay, we will find maximum value of this function. For that we differentiate this function, function 2a over x cube minus a square over x power 4, derivative will be f dash x will be minus 6a over x power 4 plus 4a square over x power 5. Okay, and for maximum minima we compare derivative to 0, and from this we will get x is equal to 2a upon 3. आप सिंप्लीफाई करो, x का वैल्यू 2a upon 3 आएगा, x power 4 gets cancel out, 2a gets cancel out, so we will have we will get minus 3 plus 2a over x is equal to 0. From this we get x is equal to 2a upon 3. Now definitely this will be point of maxima of this function. We can verify using second derivative test. Okay, we differentiate this again. Double derivative of fx will be this will be plus 24a over x power 5 minus 20a square over a power 6. Now in this put x is equal to 2a upon 3. We can take 4a upon x power 5 common and then put x is equal to 2a upon 3. We will get double derivative less than 0. X is equal to 2 upon 3 के लिए double derivative negative होगा. So this will be point of maxima for this function fx, and point of maxima of this function will be point of minima of this function. ठीक है ना, इस function का जो point of maxima है वो इस function का point of minima होगा. Okay, so this is point of minima for area function. Okay, so area will be minimum when the value of x will be 2a upon 3, and this is 2/3 of the actual width. ठीक है, ये actual width का 2/3 है. इसका मतलब क्या हुआ, the folded width will be 2/3 of the actual width when the area of the folded part is minimum. ठीक है ना. Let's start next question. Okay, now let's start this question. Find the cosine of the angle at the vertex of an isosceles triangle having the greatest area for the given constant length L of the median drawn to its lateral side. Let's draw the diagram. Diagram draw करने से कुछ समझ में आएगा हमें इक्वेशन में क्या गिवन है और क्या करना है. ठीक है, this is an isosceles triangle ABC in which AB is equal to AC. This is vertex. Okay, we have to find the cosine of this angle. Suppose this angle is theta. We have to find the value of angle theta when the area of this triangle is maximum, given that length of median drawn to its lateral side is L. These two sides are lateral sides. Okay, let's draw this median. This is midpoint of AC. Suppose this is point A, this is median. Okay, length of this median is L. Okay, so length of this median will be also L. Okay, these two medians will have same length because this is an isosceles triangle. Okay, C is also L. Okay, this is L fixed. Okay, then we have to find the angle theta, cosine of angle theta when area of this isosceles triangle will be maximum. Here this angle theta is variable. Okay, so we will try to get the area in the form of variable theta, and we will maximize that area. Okay, क्या कर सकते हैं? These two sides are equal. This side is a small c, this side is a small b, this is a small a. We have b is equal to c. Okay, so area of triangle will be, suppose area is delta, then delta will be 1 upon 2 into b into c into sine theta. B is equal to c, so we get 1 upon 2 into c square sine theta. Okay, now we'll try to get c in the form of angle theta as a function of theta. कैसे ला सकते हैं? Length of this median is given. This length is L. Okay, क्या कर सकते हैं? We can use cosine rule. Cosine rule in triangle ABD. In triangle ABD, using cosine rule, we have cos theta is equal to this side square plus this side square. This is b upon 2 because d is midpoint. Okay, so we have c square plus b square upon 4 minus opposite side square. So we have here L square over 2 into c into b upon 2. Okay, now b is equal to c, so this is here 2 gets cancelled out. We get c square plus c square upon 4, 5 upon 4 c square minus L square over c square. ठीक है यहाँ तक? Okay, so from this we can get c square. Further, this is 5 upon 4 minus L square over c square. Okay, so from this we get L square over c square is equal to 5 over 4 minus cos theta, or c square is equal to L square over 5 upon 4 minus cos theta. Okay, now we put the value of c square here. We get delta as a function of theta. Delta theta will be 1 upon 2 L square into sine theta over 5 upon 4 minus cos theta. This is area in the as a function of a variable theta. Okay, now we will find maximum value of this. For that we differentiate delta theta with respect to theta. Derivative will be d delta over d theta will be L square upon 2 multiplied by derivative of numerator into denominator, okay, minus derivative of denominator, which is plus sine theta into numerator, which is sine theta, this over square of denominator, 5 by 4 minus cos theta whole square. Okay, now we have here, this is in fact like this. Okay, we have here minus cos square theta minus sine square theta, which is 1. Okay, so we get 5 over 4 cos theta minus 1 over 5 over 4 minus cos theta whole square, this multiplied by L square by 2. Okay, now we compare derivative to 0, we get value of cos theta as 4 upon 5 or 0.8. Okay, now this is value of cos theta when this area will be maximum, because here value of cos theta is positive, so angle theta lies in first quadrant in open interval 0 to pi by 2, and in first quadrant cosine function is decreasing function. First quadrant में cosine function decrease करता है. Let's draw the graph. This is graph of cosine function in first quadrant. Okay, here we have height 0.8. Okay, this is cos theta. Cos theta is equal to 0.8. Here angle theta will be cos inverse 0.8. Okay, now just before this point, value of cos theta will be more than 0.8. है ना, इस पॉइंट से पहले cos थीटा का वैल्यू 0.8 से ज़्यादा होगा, सो दिस वैल्यू विल बी पॉजिटिव. Okay, this value will be positive. Let's draw here. Real number line, theta is cos inverse 0.8. This angle is cos inverse 0.8. Just before this expression, this expression will be positive. Okay, and after this angle, this expression will be negative, because after this point, value of cos theta will be less than 0.8, so this will be negative. That means derivative is changing its sign from plus to minus, so this will be for cos theta is equal to 0.8, we will have maximum value. Okay, this theta will be point of maximum. So value of cos theta is 0.8. We wanted this question में कहा गया है ना, find the cosine of this angle. So cosine of this angle is 0.8. Okay. Okay, we have one more question from this category. Question is, show that the height of the cylinder of the greatest volume which can be inscribed in a right circular cone of height h and semi-vertical angle alpha is 1/3 that of the cone. We are inscribing cylinder in the cone. Let's draw the diagram. We first draw cone. This is cone. Okay, this is diameter of the circular base, and this is circular base. Okay, this is center of the circular base, and this is line of symmetry of the cone which goes through the center of the base. Okay, now we are inscribing cylinder in the cone. Draw करते हैं cylinder. This is diameter of circular face of the cylinder. Okay, this is top circular face, and this is bottom circular face. Okay, and diameters of these two solid figures will coincide. दोनों के diameters coincide करेंगे. This is diameter of cylinder and this is diameter of cone. Okay, now for cone, height is given. Height of cone is given. This height is capital H. Okay, and semi-vertical angle is given. This is semi-vertical angle. This angle is alpha. Okay, so we can get radius of cone also. In this right angle triangle, we have tan alpha is equal to, suppose radius of cone is capital R. Okay, so tan alpha is equal to capital R upon capital H. Okay, so radius of cone will be H into tan alpha. You got radius. Okay, now suppose we have to maximize the volume of this inscribed cylinder. Now dimensions of the cylinder are variables. इसके dimensions ले लेते हैं. Suppose radius is small r and height is small h. This is height. Okay, small h, and radius is r. Okay, now volume of cylinder is pi r square h. This is volume. Here we have two variables r and h, so we need to connect r and h so that we can eliminate one of the variables. r and h को relate करना पड़ेगा ना, जिससे हम किसी एक variable को eliminate कर सकते हैं या कर सकेंगे. कैसे relate करेंगे r and h को? We have here similar triangles. This triangle and this triangle are similar. Okay, so we can compare the ratio of corresponding sides. We get this height will be, this will be capital H minus small h. Okay, so we get capital H minus small h, this height over this bigger height which is capital H, equal to this width. This is radius of cylinder. it is r upon radius of cone, which is capital R. Okay, so here we have relation between h and r. क्या करेंगे? We eliminate variable h. We have here 1 minus h over h is equal to r upon r. So small h will be 1 minus r over r multiplied by h. Okay. Now we put the value of h here. We get volume as function of variable r. It is v is equal to pi r square multiplied by 1 minus r over r multiplied by h. This is pi h multiplied by r square minus r cube over r. Yoga volume. Okay, this is function of variable r. So what do we differentiate this with respect to r? With respect to small r, we get dv by dr is equal to pi h multiplied by 2r minus 3r square upon capital R. Okay, compare derivative to 0, we get r is equal to 2 upon 3 multiplied by capital R. Okay, now we have to confirm that this is point of maxima. We can take help of second derivative. Second derivative d square v over dr square will be pi h multiplied by 2 minus 6r over capital R. Okay, put the value of r. It is 2 upon 3 capital R. This will be pi h into 2 minus, in fact r upon r is 2 upon 3, so we have 6 into 2 upon 3, so this is minus 2, this is less than 0, so definitely this will be point of maxima. ये point of maxima ये confirm हो गया. But we have to prove that height of the inscribed cylinder of maximum volume is 1/3 of the height of the cone. That means we have to prove that h, small h is equal to capital H upon 3. It's simple. From this we have r upon r is equal to 2 upon 3. Put this value here. We get 3h, 3 capital H minus 3 small h is equal to 2 capital H. So from this we get capital H is equal to 3h. So we get h is equal to h upon 3. तो जब इस inscribed सिलेंडर का वॉल्यूम मैक्सिमम होगा तब उसका जो हाइट है वो कोन के हाइट का 1/3 होगा. ठीक है, हाइट ऑफ सिलेंडर विल बी 1/3 ऑफ द हाइट ऑफ द कोन. ये प्रूव हो गया. समझ में आ गया? ठीक है, सिंपल है. बस हमें अच्छे से डायग्राम ड्रॉ करना है और वेरिएबल्स को कनेक्ट करना है. ठीक है. Okay, then we have one more question. Question is, from a fixed point A on the circumference of a circle of radius r, the perpendicular AY falls on the tangent at P. Then find the maximum area of triangle APY. Let's draw the figure. We have here one circle of radius r. This is circle of radius r. Okay. Now we have a fixed point A on the circumference. We have here point A on the circumference. This is a fixed point. Okay. Now from this point, perpendicular AY falls on the tangent at point P. Point P सर्कल के ऊपर है जिस पे हम एक टेंजेंट ड्रॉ कर रहे हैं. उस टेंजेंट के ऊपर हम पॉइंट A से परपेंडिकुलर ड्रॉ कर रहे हैं. तब उस पॉइंट P is here. This is point P. Okay, and this is tangent line at point P. Okay, now from point A, perpendicular AY is drawn. This is perpendicular AY where Y lies on this tangent line. Okay, then we have to find maximum area of triangle APY. Triangle APY, we have this triangle APY. हमें इस triangle का maximum area निकालना है. Okay, now tell me how can we find area function? ये function कैसे निकालेंगे area का? This is variable triangle because point P can be taken anywhere. हम point P को इस circle के ऊपर कहीं पे भी ले सकते हैं. Okay, so we have variable points P and Y. So this triangle is variable, its area will be variable. Then how can we find this variable area? कहाँ पे हम variable को introduce करें? We can introduce a variable here. Suppose this angle is theta. Angle theta is variable. Okay. Now we will try to find area in the form of this angle theta. Theta के form में area निकालते हैं. क्या कर सकते हैं? We can find this length AP in the form of theta. पहले ये length निकाल सकते हैं. Okay. Join this point of contact with the center. This is center C and center with point E. Okay. Now this is angle theta. Let me write point P here. This is angle theta. Okay. This angle is 90. So this angle will be 90 minus theta. Okay. Now this is isosceles triangle, triangle PCA because CP and CA are radii. तो ये triangle isosceles triangle हो जाएगा. So this angle is also 90 minus theta. Okay. So this angle will be 2 theta. This angle will be 2 theta. So this angle will be theta where this is perpendicular. Okay. From center we draw perpendicular to this chord AP, so it will bisect this chord. Okay, so this angle will be theta. Also this angle will be theta. Okay, now radius is r, circle का radius r है. Okay, then this length will be r sin theta. In triangle ACM, suppose this is point M where M is midpoint of AP, AM will be r sin theta. ये होगा ना r sin theta. Okay, let me write here length AM is equal to r sin theta. Okay, then AP will be 2r sin theta. AP will be 2r sin theta. Okay, now we can solve this triangle AYP. This angle is theta, hypotenuse is 2r sin theta, then opposite side will be AY will be hypotenuse multiply by sin theta, and PY will be hypotenuse 2r sin theta multiply by cos theta. है ना, ट्रिगोनोमेट्री का देखो बहुत ही अच्छा यूज कर रहे हैं यहाँ पे. Okay, by introducing angle theta which is variable. Okay, so area of triangle APY will be, suppose this area is delta, this is area of triangle APY, this will be 1 upon 2 into 4r square into sine cube theta multiply by cos theta. Okay, now we can simplify this. Here 2 gets cancelled out, we can use 2 sine theta cos theta is equal to sine 2 theta. So this will be r square sine square theta multiply by sine 2 theta. Okay, where theta belongs to open interval 0 to pi by 2. Okay, now for maximum we differentiate this with respect to theta and compare derivative to 0. Okay, so we differentiate, we get d delta by d theta is equal to, differentiate करते हैं क्या होगा इसका डेरिवेटिव. Derivative of sine square theta is 2 sine theta cos theta multiply by sine 2 theta plus sine square theta multiply by derivative of sine 2 theta which is 2 cos 2 theta. Okay, now we simplify this. Sine 2 theta is 2 sine theta cos theta. Okay, so this is 4 sine square theta cos square theta. We can take 2 sine square theta common, so we get 2r square sine square theta multiply by 2 cos square theta plus cos 2 theta is 2 cos square theta minus 1. Okay, so we get here 4 cos square theta minus 1. This is derivative. Okay, now we compare derivative to 0. We get either sin theta is equal to 0 or cos theta is equal to plus minus 1 upon 2. Sin theta is equal to 0 not possible because theta belongs to 0 to pi by 2. Also cos theta is equal to minus 1 upon 2 is नॉट पॉसिबल, ये भी पॉसिबल नहीं है, cos थीटा नेगेटिव नहीं होगा क्योंकि थीटा एक्यूट एंगल है. ठीक है, सो वी कंसीडर cos थीटा इज इक्वल टू 1 upon 2. We have only one possibility that cos theta is equal to 1 upon 2, and for this interval angle theta will be pi by 3. Angle theta pi by 3 होगा, and definitely this will be a point of maxima. We can verify with sine scheme method. Here we have factors 2 cos theta minus 1 into cos theta 2 cos theta plus 1. Sine square theta is always positive. For this values of theta 2 cos theta plus 1 is positive. Okay, now in first quadrant cosine is decreasing function. फर्स्ट क्वाड्रेंट में कोसाइन डिक्रीज करता है. ओके, सो व्हेन थीटा इज लेस देन पाई बाय 3 cos theta will be more than 1 upon 2. Okay, so before pi by 3 derivative will be positive. समझ में आ रहा है? फर्स्ट क्वाड्रेंट में कोसाइन डिक्रीज करता है, डिक्रीजिंग फंक्शन होता है फर्स्ट क्वाड्रेंट में. ओके, तो एंगल लेस देन पाई बाय 3 के लिए cos थीटा का वैल्यू 1 अपॉन 2 से ज़्यादा होगा. ओके, तो उसके लिए ये फैक्टर क्या होगा? पॉजिटिव. सो साइन ऑफ डेरिवेटिव विल बी प्लस हियर एंड देन माइनस. ओके, तो डेरिवेटिव इज चेंजिंग इट्स साइन फ्रॉम प्लस टू माइनस. ओके, सो दिस विल बी पॉइंट ऑफ मैक्सिमा, है ना, ये पॉइंट ऑफ मैक्सिमा होगा. So maximum area will be for maximum area in this we put theta is equal to pi by 3. So we get delta max is equal to r square sine square pi by 3 will be 3 upon 4 multiplied by sine 2 pi by 3. Sine 2 pi by 3 is root 3 upon 2. So this will be 3 root 3 upon 8 into r square. This is the maximum area. Okay, let's take one more example.